Hi, my name is Linnea and I'm one of the WASP Batch 1 PhD students. In this presentation I am going to talk about what I've done in my time as a PhD student at KTH, and I'm also going to tell you a bit about what I've done since graduating in 2021. So first, let me tell you a bit about what I did in my PhD project. I did my PhD at the Division of Decision and Control Systems at KTH. Here you can see a picture of me and my supervisor, Professor Bo Wahlberg, at one of the Vara demonstration days in Västervik. My field of interest has been autonomous systems and more specifically control and trajectory planning. The problem that I've been working with is that of landing an aerial vehicle autonomously on top of some sort of moving platform cooperatively, meaning that I control both of the vehicles. We have done this through a couple of case studies, one of which was landing a quadcopter on top of a moving boat. So the problem that we wanted to solve was landing some sort of aerial vehicle, in this case a quadcopter, on top of a platform on a boat, which is potentially moving at very high speeds. We realized early on that this is a very challenging maneuver for many reasons. First of all, it's a safety critical maneuver, meaning that the boat has a lot of important equipment on it that you don't want to hit with your drone. You might have crew working on the boat that you definitely don't want to hit. So there are a lot of spatial constraints on the problem where you cannot fly your drone relative to your boat. There are many disturbances, for example, wind and waves affecting your boat. There are a lot of other types of state constraints like the attitude that you're flying at or velocity and so on. And furthermore, it's a distributed control problem since we are controlling two different vehicles, and this is also something that you have to consider in your problem. So I'm not going to go into any technical details in this presentation. If you're interested, you will find my thesis online. But in the end, what we chose to do is to work with model predictive control, which is an optimization-based control framework. And we chose this for many different reasons. It computes dynamically feasible trajectories. You're always recomputing your trajectory, which means that you will at any given point have a trajectory that works right now. The constraints are included directly in the solver, so you don't have to add them afterwards. And in general, I would say that MPC is a very, very flexible framework where as long as you can formulate your problem as an optimization problem and solve it quick enough, then you can use it as MPC. So the problem in the end is how do you formulate this optimization problem? And it becomes a trade-off between how well do you want to describe reality with your problem, and how fast do you need to be able to solve the optimization problem to run it in real time. From the beginning, it was very important for us to develop algorithms that worked in reality and algorithms that could run on real systems. So for this reason, we worked a lot with simulations and experiments. We were involved from early on with Vara Public Safety, where we had access to the CV90 boat and a DJI matrice. Through Vara, we also had access to a testing area, but most of all, perhaps, we had access to other researchers that we could discuss our problem with, and also people from industry to talk to. And doing these kinds of experiments as a part of a PhD is definitely something which took a lot of time and a lot of effort. But I would say that in the end, it's really worth it because you learn a lot. And you learn a lot of both practical skills while working on these different systems, but you also get a very deep understanding of your problem when you're trying to make it work in reality. Now I'm going to talk a bit about the work that I've done since graduating. So I joined the Uppsala-based startup Air Forestry, and the idea behind the company is to completely reinvent forestry by doing finning from the air. And for those of you who are not familiar with forestry, finning is the removal of some of the trees in a forest to make room for the growth of the others. And this is something that has to be performed a couple of times during the forest life cycle to improve the growth rate of the forest. And what is done today when you want to thin a forest is that you have to use really heavy, something like 15-ton, ground vehicles, which need to cut down a network of paths throughout the forest just to be able to reach the trees that you want to remove. And since these vehicles are so heavy, they also make deep tracks in the forest ground with the risk of hurting the ground and the trees around the paths. Air Forestry wants to reinvent this step of the thinning process and remove the need for heavy, fuel-driven vehicles, therefore reducing unnecessary harm done to the forests. This video here shows the specially developed tool from Air Forestry removing the branches and cutting down a tree. After the tree has been cut down, we want to lift the tree out of the forest for collection by the forest owner. For this task, we are developing a 6.2 meter in diameter heavy lift drone that can lift the tool and the tree. This is a video showing some flights that we did before the summer of 2022, during one of the first outdoor flights that we did. The drone shown in this video is full size, so it's really exciting every time we do this kind of testing to see such a large multicopter take flight. As you can probably imagine, there are many cool things that you can do as an engineer with interest in robotics and automation at a company like Air Forestry. I'm going to list a few lines of work that I think are interesting. To take out a tree, you need to fly the drone close to the forest, place it above the tree of interest and keep it centered during the entire maneuver. And this requires a lot of precision and skill from the pilot. Automating the drone control to remove the need for a pilot has the potential of greatly increasing both the efficiency and the safety of this maneuver. And to assist with the drone flight automation, you will need a good situational awareness, which could include sensing, mapping, and localization from the air. You might also do some kind of analysis with tree population, identifying sickness in trees, or finding clusters where thinning is needed, for example. Perhaps the most interesting line of work that I see is the use of multiple drones and how they can collaborate in a safe way to thin out the forest. For improving the forestry even further, you could imagine extending the system with other types of vehicles, both in the air and on the ground. But for this large-scale system to work safely, we would need to plan multi-vehicle trajectories that are safe, as well as some kind of task planning that assigns tasks to the vehicles, make sure that they are able to complete them, and which can be updated in real time, since it's likely that unexpected things will happen during such operations. So for me, going to a tech startup after graduation was a really good choice. I think that one of the big similarities with working in a tech startup and working in academia is that you are inventing something completely new. So there is no ready solution to your problem, and you have to really be able to think outside of the box. And in that sense, the work is very innovative and creative, which is something that I think suits the people who like doing research. One of the big differences is the pace of the work. Being in a startup in general is more intense. You have to deliver results more often. But to help with this, in some cases, at least in my case, you have a lot of motivated colleagues that are really great to work with and are really all working towards a common goal, which I think is a great way to work. So now I just want to say a few concluding words to all of the people who are still in your PhD. First of all, I would recommend doing some kind of practical work as a part of your PhD. In particular, if you're not continuing in academia, it's really good to have the practical skill set as well as your scientific skill set. But also just because I think you will learn a lot about your problem when you try to implement it on a real system. And the second thing that I want to say for those of you who are thinking about what you are going to do after graduating, uh, working in a tech startup is a good continuation from being in academia, since you have these really interesting technical challenges that I think that a person who enjoys the technical and scientific process involved in academia will really like. So that's everything that I had to say. Thank you so much for listening. I've included here some links in case you're interested in learning more about the company. Thank you.